Good morning to one and all. I am Bharat Reddy from Electronics and Communication Engineering. So today my seminar includes on topic of Yagi wood antenna. So it is in the part of CA2 assignment. So coming to the introduction of my topic. So the Yagi wood antenna. So the Yagi wood antenna is commonly known as the Yagi antenna. It is a bidirectional antenna used for radio and television reception. It consists of multiple parallel elements arranged along a common axis to achieve directional gain. So the Yagi antenna is commonly also known as the Yagi antenna, and it is a directional antenna used for radio broadcasting and television reception. So it consists of multiple parallel elements arranged along common axis to achieve directional gain. And coming to historical background, let us see some historical background related to the Yagi antenna. So the Yagi antenna is developed in the year of 1926 by Japanese inventors named as Hidetsugu Yagi and Shintaro Oda. So initially used for long distance communication, and it is used later for very high frequency applications and ultra high frequency television applications. So it developed by the two scientists in the year of 1926. So scientist names are a part of Yagi Uda. It is named as Yagi Uda antenna. So it is initially used for long distance communication and later for used for a very high frequency and ultra high frequency television applications. So basic structure and components of Yagi antenna. The antenna has three main elements. So the three main elements are named as reflector, driven element, directors. So coming to the reflector is placed behind the driven element. So the driven element is connected to the transmitter or receiver. And coming to the directors, in front of the driven element to enhance directionality. And coming to the if we move on further to the principle of operation, so we see now the principle of operation of Yagi antenna. So the driven element receives or transmits the radio frequency signal. So the reflectors and directors modify the radiation pattern through mutual coupling, creating a strong lobe in one direction. So the driven element receives radio frequency signal, or it can transmit the radio frequency signal. So the reflector and directors modify the radiation pattern through mutual coupling, and they create a strong lobe in one direction. If we move on further to design parameters, coming to the design parameters of Yagi antenna, so the typical dimensions are the reflector length is approximately equal to 0.5 lambda to 0.55 lambda in axis in wavelength. Lambda represents wavelength. So the driven element is approximately equal to 0.47 lambda. So the director length is equal to 0.45 lambda, and the spacing approximately equal to 0.1 lambda to the 0.2 lambda. The gain increases with more directors. So the typical dimensions are mentioned in this slide. So coming to the radiation pattern, the radiation pattern of Yagi antenna. The Yagi antenna exhibits a unidirectional pattern with a main lobe toward the directors and a small back lobe behind the reflector. So the Yagi antenna exhibits a unidirectional pattern with the main lobe towards the directors and a small back beam behind the reflector. So coming to the feed and impedance matching. So the typically feed using a balanced to unbalanced transform. The impedance is around 20 to 70 ohms depending on element spacing and length. So the input impedance around 20 to 70 ohm depending on element spacing and length for the Yagi antenna. So coming to the performance characteristics. So the characteristics of the Yagi antenna, the gain is 7 to 13 dB, and the bandwidth is the narrow bandwidth, that is approximately to 2 to 10%, and front to the back ratio is 10 to 20 decibels, and it follows the linear polarization. Coming to the advantages and limitations. So the advantages are high gain and directivity, simple construction, lightweight. And coming to the limitations or drawbacks, it is narrow bandwidth, sensitive to element spacing, fixed frequency operation. These are the advantages and limitations of Yagi antenna. And coming to the applications, so it is applied in TV and television and frequency modulation, broadcast section, amateur radio communication, wireless data links, direction finding systems, radar systems. So these are the applications of the Yagi antenna. It is used in TV, television and frequency modulation and amateur radio communication, and usually in radio communication, and in wireless data links, direction finding systems, like in radar and radar systems also. And conclude with this slide. So the Yagi antenna remains a vital design due to its directional properties, simplicity, and effectiveness for fixed frequency communication systems. Thank you.